Good day, and thank you for the opportunity to present this project to you entitled A Time Study of the Pastel Making Process, an investigation aimed at reducing labor and time by myself, Jeselle Gajadhar, Anil Kelawan, and Jorel Bisnath. Pastels are a popular Christmas menu item for the standard Trinidadian household and are made by stuffing a cornmeal dough with a meat or vegetarian filling, wrapping in a banana leaf, and steaming or boiling on a stove top until cooked. Pastels are produced either by home cooks for personal consumption or low volume scales ranging from 6 to 20 dozen, or by well established catering companies who can produce into the hundreds of dozens for large scale corporate events at Christmas time. In catering, as with all businesses, chefs are constantly looking for ways to increase their production outputs and increase profits by reducing their production time without compromising on quality of product. Our objective was to conduct a time study of the pastel making process with the assistance of local caterers and home cooks. For this project, we set out to determine if pastels could be produced in a quicker and easier manner with minimal effort needed from the user by the design of a device. We conducted a literature review on existing technologies for local pastel production, as well as technology for similar items such as turnovers and empanadas. We conducted surveys with both producers and consumers of pastels to determine production rates, time of year for production, as well as consumption rates. We also set out to conduct time studies with local caterers and home cooks to break down the pastel making process and determine which activities within the process were the most time consuming and required effort on the part of the producer. We used the design process to develop a device to reduce the time and effort of the pastel making process and constructed an alpha prototype, which was then tested with the assistance of local caterers and home cooks. We then conducted interviews with the users of the prototype to determine the viability and any room for improvement on future prototypes. For the literature review, we first looked at locally available technology for pastel production. The manual pastel press is the most common and widely available item for this use. Its advantages include not requiring a power supply, being compact, portable, lightweight, and relatively cheap, as the price is around 150 TT. It can be found at many local groceries such as Massey stores and Extra Foods. Its disadvantages, however, is that its use is very labor intensive, time consuming, and it has an ergonomically unfriendly design. It can also only be used for the pressing part of the pastel making process and can only process one pastel at a time. The second and less common piece of technology used for local pastel production is called the Express Pastel Maker. Its advantages include not requiring a power supply, being compact, portable, lightweight, and being able to produce multiple pastels simultaneously. Its disadvantages, however, include being labor intensive, and because of the item's design, pastels are not allowed to be individually wrapped. It also does not allow for the use of a fig leaf when wrapping pastel, which is part of the traditional assembly of pastels. For devices used to make similar types of food, we reviewed a household pizza dough press. This design is very similar to the manual pastel press, with the exception of having a movable table for the dough to go into place for pressing and be removed after it's flattened. We also reviewed 2 US patents. Both designs were intended for flour tortillas. The first patent is a manual press with the ability to flatten the flour dough as well as to cook the tortilla. The second pattern consists of a mechanized conveyor and stamping press. It has the ability to run continuously, therefore pressing multiple balls of dough. Time studies were conducted with the assistance of several local caterers. The results from 2 such candidates are shown below. Candidates were timed on each activity for a total of 6 pastels. If we look at the average time between the 2 candidates for each activity, we see that folding took the longest, while pressing was the shortest activity. Another aspect of data collection was to measure the force used to press the pastel dough. This was carried out using a spring balance. From the measurements collected, the maximum force used to press the pastel dough was 200 newtons. Apart from the time study, candidates were also interviewed to determine their desired user requirements for the alpha prototype. Some design requirements include the item being made out of stainless steel to allow for easy cleanup, having a portable and lightweight item with the measurements of 1 meter long by 0.5 meters wide and 0.5 meters high so that it fit on the average kitchen countertop, being powered by 115 volts AC supply, not exceeding a cost of 6,000 TT dollars, and being able to be operated by 1 person. From the time study results, we set out to design a device that would reduce the time and effort during the folding of the pastel itself, as well as the pressing of the cornmeal dough. The ultimate goal of this design would be to either increase the number of pastels produced within a particular period of time and or decrease the effort needed by the user in producing the pastels. Here we see the final design and constructed alpha prototype. The device consists of a base, an arm support which attaches to the base, a mechanized pressing arm which attaches to the arm support. This part is used for the pressing of the pastel dough. And finally, a folding plate which moves horizontally along the base and is there to assist with the folding of the pastel once the dough has been pressed and the meat filled. Once the alpha prototype was successfully constructed, it was tested on the candidates from the manual time study. From the data collected and compared with the manual times, we see that the alpha prototype was able to standardize the press time, varying only with the user's familiarity with the device, while the fold time was able to significantly decrease. Looking at the average time taken for a user to complete 6 pastels both manually and with the use of the alpha prototype, we see that the prototype still takes slightly longer than the manual process. Based on feedback received from the users of the alpha prototype, they enjoyed its small footprint and light weight, as well as the design of the folding plate, which allowed them to fold the pastels in a shorter period of time. Areas for improvement include the positioning of the upper press plate as it blocks the view of the folding plate when a user is standing upright directly in front of the device. The speed of the pressing arm, as having it done manually was faster for some users than using the linear actuator. Placement of the fig leaf over the folding plate did not allow for the user to see where the cutout was for the dough to be flattened and shaped. And the base of the device being too small as it did not support the folding plate during the folding part of the process. Ultimately, the device was well received by the users during the testing. It was able to reduce the time taken to fold the pastels even though the pressing time increased due to the speed of the linear actuator. This of course can be adjusted in future by changing out the linear actuator for something that moves faster. By mechanizing the pressing of the pastel dough, we were able to significantly reduce the effort needed on the part of the user in flattening the pastel dough. We also observed that with continued use of the alpha prototype, the test times for the users were decreasing. Therefore, with training and continued familiarity with the device, it's possible to further reduce the production time of the pastels using the alpha prototype. Thank you for taking an interest in our project and allowing for the time to present to you today. Please feel free to contact us if you have any questions.